I just got back from a long day of hiking, and look, the stars are so clear from here. You know, seeing those stars reminds me of one of the ways navigators of the past found their way around. Today, we have things like super detailed maps and GPS, but back when we first started sailing on ships, we didn't have those tools to ensure we didn't get lost amidst the vast expanse of our oceans. Hi, I'm Annika, a second-year student studying creative technology and design at CU Boulder. Let's take a look back in time and see how the navigators of the past found their way across oceans. One of the very first ways we began navigating is called dead reckoning. Dead reckoning is the process of navigation by advancing a known position using course, speed, time, and distance to be traveled. Let's break it down. First, you mark where you're starting from on a map. Then, you want to make sure you know what direction your destination is and set a course, your intended line of travel, in that direction. Navigators determine direction using a compass, which has a magnetized needle that points toward north. Then, once you start moving, you need to track how much time has passed, which early navigators would do with clocks, and your speed, or how fast you're going. Early navigators would track their ship's speed through a process called heaving the log. Basically, they would throw a log into the water in front of the ship, begin a chant when it passed a specific mark on the ship's rail near the front of the ship, called the forward mark, and stop chanting when it passed a mark on the rail near the back of the ship, called the aft mark. Based on how much of the chant the sailors got through, they could then determine how fast the ship was going. Later on, navigators developed a method of measuring speed called the chip log. Sailors would drop a piece of wood attached to a reel of rope into the sea behind the ship. This rope would have knots tied throughout it at specific distances, and based on how many knots went overboard when a 30-second sand glass timer was done, the sailors would know what speed they were going. This is also the origin of the nautical speed unit we still use today, called the knot, as well as the idea of a ship's log, which is how we measure the speed of our ships today. Okay, great. We now know our starting point, direction, time traveled, and speed. How do we use this information to find out where we are now? Well, thanks to a helpful formula, we can determine the distance we've traveled from our speed and time, because distance equals speed times time. So, say you were walking at 5 miles per hour, and you've been traveling for 2 hours. That would mean you've moved 10 miles. Early navigators knew this, and thus could turn their measured speed and time into distance. Then they could go back to their map and know in what direction and how far away they were from the original point and mark it. Then they could keep doing that until they made landfall, or reached land, hopefully at their destination. There were some problems with dead reckoning, though. Namely, it was unreliable. Often, a ship's course made good, which is the course it actually traveled, would be different from the course a navigator originally set, with about 10% error. This is due to things like ocean currents and wind, which early navigators did not take into account when plotting a course. So, we needed a new way to navigate, and that's when we turned to the stars. Celestial navigation is using celestial objects to determine one's location. The celestial object that our navigators primarily used is Polaris, also called the North Star. You can probably guess why it's called the North Star, because it's pretty much directly north. Navigators would measure Polaris's altitude as they left home port. A star's altitude is how far away it is from the horizon. They would measure its altitude with something called a cross staff or sextant. Then, they'd sail off on their journey to wherever they were going, whether known or not. Once it was time to come home, they'd first sail either north or south to get Polaris back at the altitude they'd initially measured, and then go east or west as appropriate, while keeping Polaris at that altitude until they reached home. Seems simple, right? And it is. But what's really happening? Well, by measuring Polaris's altitude, navigators were basically measuring their latitude, or how far north or south they were. If the sailors were at 90 degrees north, meaning they were at the North Pole, Polaris would be at their zenith, meaning it would be directly above them, with an altitude of 90 degrees. If they were at the equator, meaning they were at 0 degrees, the North Star would have an altitude of 0 degrees. If they were at 30 degrees north, Polaris's altitude would be 30 degrees, and so on. However, Polaris could only be seen north of the equator, so anytime someone wanted to sail in the southern hemisphere, they would instead use constellations like the Southern Cross to determine their latitude. Measuring its altitude worked the same way as with Polaris, but would give you a latitude south of the equator rather than north of it. So, when sailing home, navigators would first get the ship at the right latitude, either with Polaris or the Southern Cross, and then sail down the latitude right back home. And that's how early navigators found their way around the oceans, when they had nothing to guide them other than the stars and measurements. But that was a long time ago. Since then, we've learned a lot more about how to navigate, and no longer have to rely on throwing logs over ships' railings and measuring the stars. But if it weren't for these early navigators, we wouldn't have the knowledge we do today. Plus, if you ever get lost, you now have another tool to find your way home. I hope to see you again soon, and until then, try not to get too lost while exploring the wide world of engineering. Check out the full lesson on TeachEngineering, then use what you learned in the associated activities Vector Voyage and the North Wall Star.